Sound travels faster on rainy day than on a dry day. Why? The amount of water vapors present in the atmosphere is much higher on a rainy day than on a dry day. As the water vapors are lighter than dry air, hence density of wet air becomes less than that of dry air. Now, because the speed of sound is inversely proportional to the square root of the density, hence sound travels faster on a rainy day than on a dry day. If the pressure of a gas at constant temperature is increased 4 times, how the velocity of sound in the gas will be affected? V is equals to root of gamma p to the power p n upon rho. Any increase in p produces corresponding increase in rho, so that p upon rho is equals to constant. Hence, the velocity of sound in a gas is independent of pressure. Explain why sound travels faster in warm air than cool air. Velocity of sound is directly proportional to the square root of the temperature of the air. V is directly proportional to root of 2 T. As temperature of the warm air is more than that of cool air, so sound travels faster in warm air than a cool air. What is the nature of thermal changes in air when sound propagates through air? The sound wave travels through air under adiabatic conditions. What characteristics of a medium determine the speed of sound waves through it? The speed of sound waves in a medium is determined by elasticity and density of the medium. If we set our watch by the sound of a distant siren, will it go slow or fast? The speed of sound in air has a finite value of nearly 350 meter per second. The sound of siren will take a finite time to reach us. Hence, the watch If we set our watch by the sound of a distant siren, will it go slow or fast? The speed of sound in air has a finite value of nearly 350 meter per second. The sound of siren will take a finite time to reach us. Hence, the watch set according to the sound of a distant siren will go slow by as much time as that taken by sound to reach us. What will be the velocity of sound in a perfectly rigid rod? Give reason. The velocity of sound in a perfectly rigid rod will be infinite. This is because the value of Young's modulus of plasticity is infinite for a perfectly rigid rod. Sound is simultaneously produced at the end of two strings of the same length, one of rubber and the other of steel. In which string will the sound reach the other end earlier and why? Speed of sound in a string is V equal to root of y upon rho, or P, you can also say P. As the value of y upon p or rho is larger for steel than for rubber, so sound will reach the other end earlier in the case of steel string.